So I'm going to change some settings that if you had been in the previous session, I think it was done by Charlie. He had also talked about disabling DNS, proxy DNS in your proxy chain files. So at this point, remember, I'm trying to speed rush some of the things that were already previously covered. So you can always go back and watch those videos if you find I have gone ahead of things. We had created SSH key on our Kali attack box, which we uploaded to the Windows machine so that we could get a reverse shell. I mean, we could pivot through that box and connect into the dev network. So in this instance, I'm just going to go straight to the part for the dev network. Let me just check something here. Okay, that's there. Okay, so first things first. I think it was shell.php. And let me just copy the code. We're done. Awesome. Okay. Shift that. Just copy it twice. So I'm just going to delete some of this lines here. So this was the reverse shell that we used to get access to the WordPress Docker instance. So the initial attack path was getting a shell via WordPress, which is in a Docker container, escape that Docker container onto that live web app machine, which is hosting the WordPress site. From there, we'll pivot into the dev network where there's a machine running, I think it's Jetty, which is a Java-based application. We'll then use log4j to abuse that and PwnKit to get previous escalation on that machine. So just bear with me. I'll try and explain as I go along, but as I said, it's a speed rush session at the moment. So X. On. And then bear with me, sometimes Cyber Rangers decides to be a bit slow, so it might be my network. That, then we did zip. Well, call it zip, and then we're going to do rev again, PHP file. So we have that ready. I believe if you had seen the previous sessions, you know that the WordPress site is sitting on the IP 192.168. Sec. Where's our scope again? 10, I think 10.20. So the WordPress, and we had already discovered that there was a user called Allison who had admin rights on this box. Admin. And we had the, after, I think if you've done the enumeration, brute force, you'd find that this user Allison has the password chocolate. Right. Yep. Save. So what we were trying to mimic was a threat actor that is scanning a target corporate a publicly accessible website. From there, they gain access into that website, privilege escalate on that box, and then try and propagate further into the network. So that's why we have to start all the way from the WordPress machine. So while that is logging in, just confirming a few things on this other side. I need to gzip minus the chisel. Chisel. So we have in this tools folder, you'll be so when you log in and you get into your Kali machine, there's this folder called tools that has a number of scripts and various tools you can use for doing various exploits along the way. So there's one called Marshall Sec. This is actually used for I think the Log4j, the dev machine. But I wouldn't be using this. I'll just use Metasploit as per what Charlie did last week or the week before. Let's see, as the login is still waiting for it to log in. Okay. Set a netcat listener. This is 1, 2, 3, 4. Got my shell. Finally, just come to plugins, add new. I'll just check something here. How to have I got the right IP. I need to modify this slightly. We should have the 140, which is the IP of this machine, the attack box. And then we're connecting to 1, 2, 3, 4. Yeah, that's good. So netcat is open on that. So do Control X, modify, save it, and then we'll have to zip it up again. So that's zip. And that. It is updated. We'll go to the WordPress, load plugin, browse, go to our tools folder. Come on, and then reverse shell, open, install. So we have our listener running. Just bear with me with this. Okay, so the moment I hit activate plugin, it should then connect back to my reverse shell. So we'll hit that and give it a second for it to get a shell. Meanwhile, I want to, okay, so we have chisels already on this side. We have a proxy set up on this side. So I guess we should be good to go to the next steps once the shell lands. Okay, there we go. So we have our shell. If I do ID, you'll see we're just www data. To escalate, and this one was pretty straightforward. If you looked at the environment, there was a password of for the DB. So this was a password reuse, I believe. If you that password, we should have a shell now as root. So if I do ID here, you'll see that I'm root. So to get a stable shell, you can do script minus QC bin and null. So we have access there as root. So now we need to do a Docker escape because we know this is a Docker container. For that, I'll straight go. I want to do the whole enumeration and all that. I'll just run the command that was used. -h unix and Docker sock run. And as I said, all this has been covered in the previous sessions. So if you're following along and you're getting confused because I'm not explaining much, this was fully explained in the previous sessions. Post. And oh, sorry, we will need to do a bit. We need to find the images that are running. And this time. The WordPress image, which is this one. Bash. So you can see now we've changed. Oh, sorry, there's some missing commands there. So then run -v post. Then we have this bit. So now we can see from the root WordPress, it has changed to a different machine. Now with that, I'll just upload what do you call it, public key that I generated previously. So if you watched the video that Charles did, it's shown the steps to generate your key. So I'm just going to use SCP to push that to the machine. Just 1 second. Keychain. Sorry, I need to first change something here. Right. I need to echo. Sorry, I need to cut the. Come on. Exploit.pub. Copy this. And then we're going to also copy that. We're going to echo. Switch to documentation. So we're coming here. CD root. Then do ls minus l a, get. Am I missing something? Copy the exploit path and switch to the. How come I don't see the .sh? CD slash post first. Then now if we see in LA, we'll get the SSH file should be, yeah. So now we are going to go to cd.ssh. Then from there, you could do ls, you should see authorized keys. Yeah, so we're going to do echo. The key we copied from this side. Oops, sorry, not that screen, the other one. Just do that. Come here, place it here. And don't mind the text as you see it, it's copied with some other characters. Once you've echoed that, we will push that into the authorized this file. Yep. It's done. So if we do cut, authorized keys. Let's see the file there or the details there. It's the last one, so that's all good. Now, with that done, we can. Okay. So with the key now copied across, we can go back to our Kali machine and SSH now to that using the key we've generated called exploit. And we're going to go to root at 192.168.10.20, which is the IP that's hosting the WordPress machine. Say yes. And we're in. So we've completed the first attack. We've gotten root onto that machine. So now at this point, we want to pivot to the dev network, because if you do an ls here, you'll see there's a file called notes. You open that, it tells you that you need to migrate into this network of 192.168.2.0/24. So to do that, you had seen me previously opening, what do you call it? On the CD, let me just go to that folder and you'll see. So in my tools folder, I have chisel. I extracted chisel. Let's make sure it's executable. X chisel. Just add sudo just in case it asks me for that. So if we now do ls, you should see chisel should be in green, which means it's executable. And now I want to push this to that server. So I'll do SCP -I using the key exploit. The file I want to send over to that server is chisel. And of course, the login 2.168.10.20. And then the location where we want to save it. So we want to save it in root and file name is chisel. That's gone. So you can see the file has been uploaded. If I come to that box here and see which directory are we in. We're in root. So if I do ls, you'll see the chisel file is here. And it's ready to be run. So before we do that, don't think I need this one anymore. So I'll just close this. This. Hope it dies. Good. Come here, cd into the tools folder. So with Chisel, we need to, it's a server client-based application. So we'll have to start a server on our Kali machine. And remember, we're going to be using proxy chains to push our traffic through this Chisel tunnel that's created. So that's why one thing to note, you need to modify your proxychains.conf file, which is located in the etc folder. You see it, proxy chains profile. And I'll just do the last bit so that you see what the last configuration is. It's SOX 5, and I've left it on the default of port 1080. So knowing that, let's just do chisel, chisel, and this is going to be server. And then the port we want to connect through is going to be 8001. And we're going to say this readers. So we have our Chisel server up and running. On the live web app machine is now where we start the client side. So we do Chisel, client, and this is going to be the IP of the listening or the server where it's connecting to. So this is going to be 125.140, and the port we had set on it, which was the 8001, and we're routing the 1080 as per the proxy chains, and we're using SOX. And we can see that we have a tunnel connection from this machine. So the next bit. So basically what we have done right now is through Chisel, we have opened a proxy on the Kali machine, and we're tunneling through that to the web server. So basically all the traffic that we want to, all the packets that we want to send to that other network, which is the dev network, is going to be tunneled through this Chisel onto that live web server, and then we can connect back into the internal networks. So for now, as I said, I'm speed running. This was also previously covered. So we're now going to try and get into the dev machine. If you really want to know what's running on the dev machine, we can do proxy chains. Come on. -Q to silence any output that you don't want to come to the screen. Curl -I. And on that network, if you did a ping sweep, which is what Charles had covered, you'll notice there were some other machines on the network, because we already know what we're trying to target. That machine is sitting on 192.168.2.60. And if we're done like an nmap, you'd have found that this was running on port 8080. So if you run that, you can see there's a Jetty server with this version. And if you Google and researched about it, you might find that, or you'll find that it runs Java applications. And so we know that log4j shell was the recent attack that could be used to leverage to get a shell on it. So what we're going to do is quickly just do proxy chains again. And this time we're going to launch Metasploit or MSF console. So we'll give that a second to load. So basically what we're going to do is using Metasploit, we're going to send the already inbuilt, it has an exploit module for log4j shell. And basically, it's going to generate the payload for us and send that over to that machine and give us a shell back. So to do that, we can just do search log4 and see what it gives us. So basically, we're going to use this first one, exploit HTTP log4 shell. So you can just do use 0. And if we clear the screen first, there's two options. There's a certain variables that need to be set. So the first one, of course, is the L host, which is the listening host of our server. In our case, is 192.168.125.140. Then what are the other options we have? So we need to set the, sorry, it's going a bit far. We need to set the R hosts and the R port as well. So for R hosts, it's the attacking or the vulnerable machine. R hosts 192.168.2.60. We need to give it the port because it's not using the default one. So R port, okay, 8080. We need to also set the SRV host. And this should be our attack machine again. 68.125. 140. And if I clear the screen and do options, I think we should be set to exploit. Yep, we have all the options we need. There we go, 80, that. Yep. So just run exploit. And this will do all the heavy lifting for you to send the payload to that server and execute it and get us a reverse shell. Okay, so we should be having our shell back just to test. We can do a who am I. It may look like there's nothing, but there is a shell. Server website. So I've opened another tab here. What I'm just doing is because I want to also upload Chisel to this server. I am just keeping a simple HTTP server running on this side. Sorry, simple, but HTTP server. That's simple HTTP was Python 2. So server, and then I'll give it a port of 9090. So we can be able to upload files from here. Come back to this guy, and you can see when I run who am I, we have EvoCorp. So I can try and get a stable shell again. So I can do script minus QC in bash dev null. Yep, so we have that ready. Do I need to do PwnKit? No, I can just run Chisel here. So I'll just do wget. Okay, before I do that, If I do if config on this machine, it will give us the IPs. Oh, sorry. Let's see. Do IPA. Yep. So you can see there's two network cards. So right now we have been using this one to attack it. And you notice there is another IP of 1.60. So that's the internal, the third network that we need to reach, which would be where the AD and the Windows machines are. So before we get that, we need to, of course, download our chisel to this server. And that would be 192.168.125.140, port 9090, chisel. So we have chisel on this machine now, on this place. Make sure it's executable. Okay, so now we'll start chisel server, I mean, the client again on this side. Chisel, commands again. So client. And then we can give it the server IP that's listening, which is our attack box dot 140.8001 R. And since we already have this previous one listening there, we will need to change our proxy chains file. So we'll just do that on this other tab. D nano C proxy chains. Sorry. Sorry, we need to do this in sudo. Sudo nano. Right at the end, and we'll just change the port for the proxy change to something else. So in this instance, I'll just change this to 1090. Save this, and we pray everything works. So we come back on this side, and we're going to specify 1090 port and pushing that to 8001. Oh, sorry, to SOCKS, not 8001. So with that, you can see it's connected. So everything should be running, and we should be able to now communicate into that internal network of 192.168 1.60. So for that, we can now come and leverage proxy chains again. Chains minus Q. Should I do a full nmap for? Okay, so since we know we're on that one network, we need to identify which machines could be there. There is something we can do called a ping sweep. So you will get to see all the machines there, but we will have to do that on this side now. Let me see if I can, if I stop the chisel. Yeah, since we're doing this through Metasploit, I'm just going to do background on this. Say yes. And then I'll exploit again and get another shell. And from that shell, we can do the ping sweep. So I have a cheat sheet sort of for the ping sweep. So let me just copy that. I'll have to drag and drop it. So let it load here. Give it a second. It should tell us exploit done, and then We have a fresh shell, which we can then now leverage the ping sweep to see which are the different, okay, we have it there, which are the different machines that are on this network. So again, I'll just give OMI to see that we have everything there. I'll wait for that. I'll make sure I copy to get the interactive shell. Let's use this again. Still waiting, so just give that a second. And because this is proxying through a tunnel, it takes some time before responses come, so it's a bit slower than even normal. So we have that. We can get our interactive shell going. And then I'm going to copy this ping sweep command, which was also shared by Charles last time. I don't know why it keeps on copying twice, so just bear with me while I edit some of these things. Let me just do that. And I will copy it again from here. And you can see it has done the full, but I just wanted to grab a few of them. There we go. Come on, slowly, there. So copying this till grab from. Sorry. Shift first, close this guy so that it doesn't disturb us. Control Shift, copy this, Control Shift V this, and press enter. And now you can see we have these 1, 2, 3, 4, 5, 6 machines or devices that are replying. Now you'll notice from the TTL, 4 of them, or rather 5 of them are showing 64 and 1 of them is 128. If for those of you who are familiar with these numbers, 64 tends to be Linux or Unix based machines, and 128 tends to be Windows machines. So we can already identify that this could be potentially a Windows machine that we can attack, because we know now we're getting into that network and we don't need to, and 60 is our current machine that we're tunneling through. 140 and 2. So we'll not bother with these. Just bear with me. Since we don't want to waste too much time, we go straight for this 115 box. So to do that, we can come to this other tab, run proxy chains, and we'll just do an nmap. Come on. Minus SC minus SV minus PN. What else was there? There's a minus, was it ST? ST. We're going to specify a specific port since we know it's a Windows machine, and to save on time because we're running it through proxy chains. I'm just going to go for port 445 and the IP for we got, which was 1.15, and see what we have on that. And if all goes well, we should get some form of output that it is a Windows machine. And I believe port 445 should be accessible on this one. If you're doing the CTF, you would have definitely poked around all the other ports that are there. But just for brevity, I'm going through what would be the direct attack path, because it's pretty long what we need to do. I hope we'll be able to cover it, but I believe we'll try our best to make sure we do all of it. So the output has come out. So we can see that this is a Windows Server box. Let me just push this up so we get a bit more real estate to read. So we can see this is a domain controller because it's running Windows Server 2016, and it's also got the name DC. So you can already tell that this could be a domain controller, and we have the full domain name that it's using. So with this info, we can now start looking at what sort of information. And since we know port 445 is open on this box, I'll just switch to the tools folder here for 1 sec. And from here, I want to poke into this. Port 445 is usually used for file shares. So basically what we want to do is enumerate the different files that could be, or shared folders that could be accessible on this server. So we'll be using proxy chains, then assembly client, and we want to list the folders that are on this machine. 15. Or I should have put the quiet, but it's okay. So we can see a number of folders. Again, because of brevity, I'm just going to go straight to where the attack was supposed to be. But of course, if you're doing the CTF, you'd have poked through the different folders to finally get what you're looking for. So again, I'm going to run proxy chains. This time I'm going to ensure I put the -Q so that it's quiet. We're going to now change this to N. And here we're going to do that. And we want to access the file which is going to be in the public folder. So if we do that, sorry, it's not N, but oh, I've missed one character space. And because we don't have any password as yet on this network, so what has happened is in this scenario, the domain controller was set up with what's called anonymous login. So using the SMB client and using the -N switch, that's basically telling it to access any shares available with an anonymous login, meaning you don't need to supply a username or password. So if we do that, we're into that box, or rather into that share folder. And if we do an ls, it will list out what files are there. So this is what I was saying, you'd have enumerated the other publicly the other accessible folders. But once you get here, you'll notice there's a config file called test config. So basically what we want is to bring that file to our curly box and investigate it further. So test config .xml, and you can see the file is brought. So if I exit here, this do ls, you can see there is a file called test config. So if I cut this, we get some details, and usually this sort of a file is used for configuring domains that are using group policy preferences. So if you Google this, what do I call it? The C password in an XML, you go this, just open here. You can see there's already a search that gives you to decrypt. There's this tool called GPP decrypt, which is already on your curly box. So what we'll just do is GPP decrypt and supply it. So you can see in this file, there is a domain, of course, and there's a user called J. Mickelson or Mikeson, however you want to pronounce that. And there is a C password, which is an encrypted password. So if you Google and read much more on this, you'll notice that when you're using group policy preferences, the files have an encrypted password that it uses to push whatever policy or configurations you're trying to push on the box. So in this instance, we want to decrypt this password. If we're successful, we are going to have the password for the user, Jim Mickelson. So if we do that, we get the password. So we're already one step in. We have now a domain user. So the next thing which most threat actors or hackers supposed to do when you're doing a pen test is, of course, try and spray that account details across the network to see where you may have access. So we can run proxy chains again, -q, but this time we're going to use another tool called crackmap exec. Map exec. Then we're going to use the SMB protocol, and then we're spraying this across the whole range of 24. We're going to supply the username of J Mickelson, the password we've just taken, which is put it in that ABCD at 1, 2, come on, 1, 2, 3. And do I need to supply? I'll just supply the domain, which is evilcorp.com. And let's see if this user is actually a valid user. So we are a valid user. And do we have any privileges on the domain or any other machine on the domain or on the network? Remember, when we did the ping sweep, we only found the domain controller, but in the scenario, we actually have 2 other machines that are part of the network. It's just because of the configuration and firewall rules, ping has been disabled, so you would not have seen them. So we can see that this user is a valid user, but has no further privileges to maybe access any machines on the domain. So the next thing you can try, we're going to try and do is we're going to see if we can get some output from this network, because some of the questions in the, if you see the, so why is this gone all the way here? Just run to the lobbies. Okay, this is hanging. Why? Shoot. Let me plug in this guy first while you're doing that and see if you can. Hi guys, sorry my machine, you know how tech works. It just decided to go bonkers on me. So let me share my screen. And if somebody could just put it in the chat if you can hear me and you can see my screen.
Yes, we can hear you and see your screen.
Perfect. Awesome. So we were at this point where we cracked the password for the JMixin user, and using proxy chains and crack map exec, we sprayed their credential across the network and found it is a valid user but has no code execution on any machine. So the next thing we need to do is, because some of the questions that were there for the flags that were related to this specific what do you call it, AD was attack phase required enumeration. So you can see the questions here. What is the name of the file that contains the password of the domain? We already know that. So since we're going to do domain enumeration, one of the awesome tools that's out there to do this is called Bloodhound. And basically, Bloodhound takes a snapshot or captures information from the domain controller, as well as depending on the method you use. It also queries machines, maybe looking for logged on sessions for administrators or any other domain account. So before you get to use Bloodhound, you need to collect that information. So there's a tool known as SharpHound that's there to be able to help attackers or threat actors or pen testers get that information. So we'll go straight into that. If you look in this tools folder, there is a Python repository. So SharpHound is actually designed by the guys who wrote Bloodhound. But because we're going to be doing this from a Linux machine, we're going to leverage a tool called, I think it's called Bloodhound Python or Python Bloodhound. Let me just check it in this folder. Yeah, so it's a Python script that will output information from Bloodhound. It's actually available from this repo on Python ingest. Yeah, foxit-bloodhound.py. Sorry, that's going to be this. So basically, this is a tool that will allow us, using Python, to be able to get the details we need to push into the Bloodhound tools that will map out for us, maybe attack paths that we can figure out. So getting back to our Kali VM, just clear that thing and do again proxy chains, because we are tunneling through the chisel session that was still we had initially set up. Come on, if we could type properly, -Q. We're then going to push this to the Bloodhound, which is through Python 3. This is in Bloodhound. It's called Bloodhound Py. Then we're going to specify collection method as all. And we're going to give our user that we found, which was Jay Michelson. We're going to supply the password, which was ABC at, was it ABCD? Yeah, ABCD at 123. Then we're going to give it the domain controller, which we had seen in the Nmap scan was called DC01 dot evilcorp. So this, you have to give it a fully qualified domain name, evilcorp.com. And we're going to give it the NS server, name server, which is the same as the domain controller, 1.15. And we're going to say we don't want to use UDP, so we're going to use DNS TCP. So what this is going to do is it's going to go and query the domain controller and pick out information. Is it saying DNS timeout? Proxy chain at DC 453. Huh. Why is this failing? Let's see, is the chisel. Yep, we're connected. That's running. That's session 2. So let's see, we have all, Microsoft password is correct, domain controller is set, NS is set. Oh, let's supply the domain. Sorry, I forgot to add one more switch here. Which is evilcorp.com. And this should work. Yep. So now you can see we also, from the query that's coming back, we can see there are 3 other machines apart from the domain controller. You have a file server, you have an MS SQL server, you have a workstation, and of course the domain controller itself. Once this has completed and we ls this folder, we'll be able to see some JSON files that have been created. And basically these JSON files are the details that we need to feed into Bloodhound for us to get it to map out these the details about the domain. So to use Bloodhound, let me just open another thing on the right. There are 2 things you need to have set up. So one, you need Neo4j because Bloodhound uses Neo4j database to store the data and use GraphQL to then map it out for us. So Neo4j is already installed in these machines, but they're not fully configured. So if you're following along, one of the things you'll have to do is set up the initial password for Neo4j. So simply just run Neo4j console. And once that starts up, it'll give us a link, which will then give us the ability to reset that password so that we can then load the Bloodhound dashboard. So we'll see, is it localhost serverless? There we go. This open link. So the default password for Neo4j, which is the same for you when you do this on the range, is Neo4j, and the password is Neo4j. Once you connect for the first time, it will present you with a screen to reset that password. So you can choose now the password of your choice. So for my instance, I'm using Bloodhound. And again, I'll set it as Bloodhound. Change password, get a success. Yep, and that's done. So now we can go back and launch Bloodhound. And it'll ask us to log in here. So we will use the username and password. We'll use the username and password that we've just set up. And now, when you log in for the first time, you'll be brought up with a blank. If it's you have not used Bloodhound before, it's usually going to be empty and pretty blank. As you can see, there's nothing in the database. So what we need to do is just simply drag and drop those JSON files that are in our tools folder. So we go to come here, come to Kali tools, and then select these 4 JSON files. So this is, you can see this is details about computers on the domain. This is information about the domain. These are groups and the users that are there in this EvilCorp domain. So simply just drag and drop. It will start uploading. Once these reach 100%, you can start seeing it's already populating some information for us. And once that is done, we can simply close this. And when we come to this side, we can go to analysis. And there are lots of pre-built queries that are there in Bloodhound. So these are like things you can use to quickly like find, let's see if we want to see who are the admins, find computers where domain. Yeah, so find all domain admins, little query, and you can see we only have the administrator as the domain admin. I would highly recommend you guys to go through the various queries that are there. And then the beauty also of Bloodhound is that you can, since it uses GraphQL, you can customize and write your own sort of queries. So to answer some of the questions that were there, I think, let's see which one we have here. So like this example, which is what is the object ID of the CTO from the full ID. So to get this object ID, and I want to use Bloodhound, and it's specifically asking for who is the CTO, we can simply run a query here. So we're going to say match, and we're going to use users. So we're going to give it a variable and pass our users. And we're going to return that variable. So it will give us all the users that are part of this domain. All right, that should do it. Did I mistype something? Match users, return you. Oh, why did that not work? No data returned from query. Do I have these users? Let's see if I go to users. Okay, the group is there. So out of space. Oh, that's weird. Again, issues. Users, spelling is correct. Without an S. That's user, sorry, singular. So you can see these are all the different users that are there in this domain. So of course, the city of challenge would mean you'd go enumerating one by one. I know who I'm looking for in this case, who is the CTO. It's T. Wellick. So if you click on this user to prove that it is that CTO, once you click that user, you get the node information. So you can see we use on this user T. Wellick. And it's actually the full names are Tyrell Wellick, and he is the CTO. And this is the flag that we needed to submit. So that's the object ID. So basically, using Bloodhound, you would have been able to answer a number of the enumeration questions. Check another one, like what is the name of Jerry Mixon's machine? So you can go querying through the machines as well. So to do that, you just simply replace user here with computer. And you can see it gives us these, I believe, we look at through the, where is it? Where is it? Yeah, I think it's workstation 2. Should tell us that this is in the description. Yeah, so this is Jeremy Mixon's machine. It's a bit hidden, but yeah, that would have answered the question for this question. So we know the answer is workstation 2. So basically, that's how I said you can use Bloodhound to enumerate and answer those questions. So we're pretty much done with that. But for the next attack phase, so that we know, I mean, Bloodhound is supposed to help us get various attack paths on the AD. We'll just use the pre-built queries. And there's usually a common attack that people leverage, which is cover roasting. So we'll just go straight to that. We can do shortest paths, not from cover roastable users. Sorry, that's not what I was looking for. Just bear with me. We'll give an error. I want to know list. Yeah, list all cover roastable users. That's the one. So you can see now we have two accounts. There's a Care BTGT account and the help desk account. Now this account is always available on the domain controllers or AD environments, because this is what's used to encrypt the what do you call it, the Kerberos authentication keys that are used. So these are your ticket granting tickets, or sorry, not your ticket granting tickets, but your ticket granting ticket service tickets, right? If that makes sense. But I'm not going to cover Kerberos and all that right now. That's an AD attack path. So we know the next thing we can try and do is try and Kerberos this help desk user. So with that, I'm just going to close Bloodhound because I don't need it anymore, and go straight to Kerberosting this user so that we can see how else we can get more foothold into this network. So remember, right now, all we have is this J. Mickelson's account and the password, but we don't have any code execution on any of the machines on this network. So to be able to Kerberos, we can use the get SPN thing. But before we do that, sorry, even before Kerberosting, we could have checked on the domain. Sorry, I should have left that hand open, my bad. So one thing I'll show you before we go to Kerberosting. 4J. This is Bloodhound. And we should still have the data we had. We were checking on computers. So come here. We'll do match. You to computer and return you. So of interest to me is this machine. And if you check through the node properties, you can see there's some SPN, which is service principal names that have been set up for this machine. So you can see this time. Sorry, we can see that this is set up to delegate. So one thing we will know how to attack from the next bit is using these delegations. So this machine is actually set up for constrained delegation, which we could have enumerated through here. So this is unconstrained. Where's the constrained delegation? Dangerous rights, parts, reverse interaction. But anyway, so what you need to know, which is of key importance, as I mentioned, is that this machine has delegation rights set up for it, and we can see how we can leverage those to attack it. But we know we want to Kerberos that help desk user, so we'll use the get the impacket tool, which is located in the CD user share. Then we go to impacket. And we go to Python 3. Wait till it's impacket. Sorry, share doc, then impacket. Doc, then Python 3, impacket, examples. Cool. If we list this, you'll see a number of tools we can leverage. So again, we'll do proxy chains. Q. Minus Q. Then get SPN. Come on. Get NP. No, let's get user SPN, sorry. On the pi, then we'll supply the domain corp.com. Make sure you have the .com bit. And then the user is J. Michelson. We're going to supply the password, which is ABCD at 123. And we're going to give it the IP of the DC, which is 192.168.1.15. And we're going to give it an output file. So we'll do minus output. File, come on. Set this to that tools folder and call it hashes dot curb. Let's see. Now, if we get an what is this? Oh, sorry, I'm supposed to have supplied a Python 3 at the start of this. User domain should be specified in IP. That. Sorry, it's there's a syntax error. It should be that way. So you'll probably get this error where the skew clock is too great. And to resolve that is because your Kali attack box needs to be within a plus minus of, I think it's 5 minutes within what the domain controller's timestamp is. So to get us to that, we will use the nmap script again to get the current time of the server and then calculate what we need to set our Kali attack box to so that we can leverage Kerberos. So to do that, we do proxy chains again. Minus Q and map minus PN. We want our port 445 just to make things faster. 5. IP is 192.168.1.15. Let's get that details. Oh, sorry, I need to supply the minus S aside from just the minus PN so that we can get a bit more information. Minus SC minus SV, capital V. So you notice you can see the nmap even on the screen shows that it's running in EDT. So that will give us some details. This is our current time. I mean, no, that's the EDT current time. So let's see what the server timestamp is, and then we'll need to adjust our machine clock or machine time to match that of the domain controller so that we can leverage Kerberos to at least extract this hash for this user or any user that is Kerberosable, which we know in our instance is the help desk user. So just give that a second to run. Meanwhile, I'm just going to jump into the chat to see if there's any questions. Yeah, John Collins, we are actually using the get to use SPN, but because you didn't know that is why we had to use Bloodhound to enumerate, because you just don't want to run Kerberosting without knowing if there's actually any user who is Kerberostable. So what I'll do just to help you guys, I'm also just going to copy that command. Let's see if it will allow me to. Shift, yes, it is copied. Shift, and I'll drop it in the chat for you guys. All right, so the nmap has completed, and we can see that we are there's a clock skew of almost 1 hour 19 minutes. So we need to now match our time to that of the domain controller. So I'll just again for real estate. In fact, I'm done with Neo4j, so I'm just going to close that as well. Clear out some stuff from the screen. Cool. So now you can see the date and time is 1640 here, whereas on our machine we're at 1740, which is different. I believe this should be in UTC, while Nmap here, you can see it's running in EDT. If you quickly just did EDT to UTC, you'll notice that it's usually about a 4-hour difference. So we need to set our machine, our attack box, the Kali machine's time to 4 hours behind of our current, what the domain controller is running on. Where is that? That's if that's 16, that should be 1240. So sudo date minus s 1240. And that's been done. So now if you come back and try running our attack, if all has gone well, it should, yep. CC cache file is not found skipping. Why is that? Let me just cd to tools. Yes. Yeah, we have our hashes file. So if I cut the hash file here, you can see we have the hash for the help desk account. So next we're going to run, we're going to try and crack this, hoping that this user is using a weak password. And again, in this tools folder, there's the RockU text file, the word list. So we'll just leverage John the Ripper. So we'll run John, we'll just apply the word list, which is equals to RockU, and then the hashes file. Oops, hashes, come on. And let that run. So if we're successful, if this password exists in this RockU file, we'll have the password for the help desk account. And voila. So we have the account password, and now we can leverage again crack map exec to see if this help desk account has any access on any other machine on the network. So we'll do proxy chains minus q crack map. Come on. Exec SMB. And we're going to supply minus u help desk minus p. The password we've just found. So because of the @ sign in the password, I recommend putting it within single quotes, because sometimes it might cut out either the @ or the $sign. So give it that. Then the range we want to give this to is the whole subnet 168.1.0/24. Why is it giving me that? Oh, sorry. The range should come before all these details, so it should be right after SMB. My bad syntax. 68.1.0/24. Sorry, I've seen another syntax error. Where is 25245 coming from? That's there. Let's see, everything is okay. Help desk that. I'll just apply the domain at the end. Corp.com. And this time you should be good to go. Yeah. So again, this is a valid credential. It's using SMB to try and authenticate on the network. But again, you can see we don't have a pond sign. So that means this user still doesn't have access to anything where it can do some code execution. Just to save on time, because I can see we're getting to almost 9 o'clock. I'm just going to stop this and I'm going to run the same attack, but now with WinRM. Because CrackMap exec gives us the ability to test out on different protocols. So let me just see if this user has anything in WinRM. And voila, we have pond on the .50, 1.50 machine. So I'll just, again, just to speed things up, I'll just stop that. And you can see this is WinRM. So basically, there's another tool we'll leverage here called Evil WinRM that will allow us to get like a shell on that machine. And it usually gives us a PowerShell machine, a PowerShell session on that machine because this is running Windows. So the syntax for that, 1 second, is going to be where we. Yep. So we're going to do proxy chains again. Minus Q, evil WinRM, minus I. Supply, that's going to be the machine that we're targeting, which is 1.50. Go back at 50. Then we're going to give it the username, which is help desk. We're going to give it the password, which we have here. This, yeah. And then what else do we need? So as mentioned previously in the, so just clear here, so that is done. CD tools. You'll notice that there's some PowerShell scripts that are supplied in this tools folder. So like invoke, mimikatz, print, nightmare. So that should already give you some form of clue of what you can try and do on these various machines that we attack. So the beauty about Evil WinRM, if you use the -S switch, it allows you to load the folder that contains your PowerShell scripts. So I'll supply that. And we're now on that box as that help desk user. If we do host name, we can find out what machine we're on. You can see we're on the file server. If we do a who am I as this help desk user, sorry, who am I priv, this is to see what sort of privileges we have. We don't have much privileges, and therefore there's nothing much we can do. But if you look at the tools folder, we have a print nightmare PowerShell script. So we'll just leverage that to gain privilege escalation on this box. So you can just do print nightmare.ps1. It will load that script into memory. Once that has loaded, to use it, you could simply just do cat print nightmare, so you can understand the syntax of what you want to do. Actually, just do head. You just need the initial part. You can see the function that we're going to call is invoke nightmare. So once you've loaded the PowerShell script, we'll just do invoke nightmare. Come on. And you can see that is completed. So it has created a new user on this box called admin and using this password. So this is, if we go to net, is it net group? No, net local groups. Group administrators. you'll see that admin account that we just created is now part of this list. So now we have an account that we know, a local account that has administrative access to this box. So basically we can now exit out of this shell. Again, proxy change, but this time now we will log into that same machine using the new credentials that we have. So this is going to be, let's just copy it from here. And this is going to change to admin. Come on, JDM1N. And we're going to still supply the tools folder because we want to leverage another script. Now, knowing that we are administrators, as we can see from here, we can see what else we have. Now you can see we have full control. We can do a lot more on the machine. And there's an interesting script here called invoke Mimikatz. To anybody who doesn't know about this, Mimikatz is a tool to dump out passwords from memory of Windows machines. And of course, you need to have administrative privileges. So the fact that it is in your tools folder, it's sort of an indicator that we need to use it. So again, we can just invoke Mimikatz, bring it here. And we can also cut, or rather head invoke Mimikatz and see what the function call is. So the function we're going to use is invoke Mimikatz once again. So once it loads here, let's see what sort of credentials we can extract from this box. Oh, and mind you, now that we're also admin, if you went and checked the flags, there are some flags for the AD boxes. So for example, this one, which would be located as per the instructions given in your overview. You'll be told that there are some flags that are in the folder. So this is for the, I think, yeah, administrator desktop for Windows boxes. So all three machines in the domain have a flag in the admin folder. So for that, you could have simply done cat, no, it's type, sorry, this is not Linux, type C users administrator desktop. In fact, let's start with ls so that we know what the file is called. It's called flag9, so we'll simply do that. Boom. Type that, and this is flag9. So that's how you'd have got the first flag or popping your box. Now that we have that, as I said, we're going to use Mimikatz to dump out any credentials that could be on this machine. So basically what this does is it targets the LSAS process on Windows machines. And whenever you log into your machine on a Windows machine, even if it's through remote desktop or accessing through a service, your password gets stored in that LSAS process. So even if we may not have an interactive session on that machine, the password gets saved there until the next reboot. So you can see this has dumped out some information. So that's the Mimikatz script. There we go. And immediately you can see we have another user that we didn't have before called app service. And we even have the clear text password for this account. So just like before, we can again leverage crackmap exec and see where this user has access to. So let's go to proxy chains, crackmap exec. We'll just do SMB. We'll change the password here. This is supposed to be app service. See. It's a valid user. Okay, so nothing. Let's try with WinRM. Maybe we have somewhere else we can access. Okay, so cool. We have now the .20 box. So I'm just going to cancel that for brevity and use again Evil WinRM with now this new account and see what we can do on that box. So I will do let's just go up Evil WinRM. There we go. Change this to this. And then this should be .20. And this should be app service. Run that in. Now this time, if I do who am I priv, you can see we already have full administrative access, so you don't need to really privilege escalate. So this was pretty much as an easy flag, I guess, because you don't have to do much more on this box in terms of privilege escalation. So again, the same thing, you can type C user administrator and the flag file and get the output for that and submit it, but we'll just save time and not go through that. Now, we have pawned 2 boxes so far, and we're still not yet got the domain controller. So when we did the Bloodhound enumeration, we're supposed to have seen that this machine has, what do you call it? The, how do I call it? Constrained delegation set up for it. So for us to be able to now abuse that, how constrained delegation works is that the server that has been set up to request tickets on behalf of a user will use its machine hash to then communicate to the domain controller. I might be using a bit more very technical terms, but it's because of time I'm trying to just rush and give an overview explanation of it. So technically what happens is this is a scenario where a machine has been set up. So an example would be you have an SQL database and there's a web application. So when a user logs onto the web application, they don't necessarily have to supply their password again on the SQL server for them to be able to access data from it. So that password they log in at the web server is then pushed to the MS SQL instance. It will then request a ticket on behalf of that user to the domain controller. If the user is valid and allowed to access the service, it will return that ticket and the user will be able to get the data from there. So that's what the whole Kerberos chain was built around. And with the constrained delegation, this machine hash is a very key thing because that's what's used to then a request for the user's authentication. So to do the next part of the attack, what we're going to do, because we knew that this, as if we do, by the way, didn't check even which machine this .20 is. So exactly on this, I do host name. It should be the MS SQL machine that we talked about. Even we saw it in the Bloodhound output that it was set up for delegation, and there were certain services that it was set up to delegate for. So to now abuse this, and basically with unconstrained delegation, there's a technique you can use whereby, because as I mentioned, it takes the requesting user's hash and supplies it back to the server, we can force and since we have administrative rights on this machine, we can sniff for any any hashes that are supplied to this machine whenever some user logs into it. But that's why I said the LSAS process and all that works in that way. Now this is using Kerberos. when the user authenticates, this account is, or rather his hash is supplied to the domain controller. And now, since we have administrative rights on this machine, we can sniff for any user that is trying to authenticate on this machine. The other beauty about this attack is we can also force specific users, like for example, an admin to like log into it, or even another account like a machine account. So in the domain context, when we talk of machines and users, they all have passwords. So what we're going to try and leverage for this final attack is try and force the domain controller to authenticate to this MS SQL box so that we can steal the domain controller's password and then continue the attack and escalate our privileges into that, pivot into that machine. So to do all that, the first thing we're going to do is we need the machine account for this MS SQL server. So again, we're going to leverage Mimikatz for that. So we go to invoke Mimikatz, load it. And another tool we will need to sniff for these passwords is Rubius. So we will also need to copy or execute Rubius on this machine at one point. But for now, let's get the machine account hash for this, and then we'll see how to leverage that. Okay, so we have Mimikatz loaded in memory. Again, we will just invoke Mimikatz, but without the PS1. So this is when I talk of a machine hash, you can see we know our machine is called MS SQL, and you'll always find, you can see it's showing here as a user because the domain looks at the machine as a user. And you'll always find machine accounts are appended with a $ at the end. So every time you see anything that has like a $ at the end, that's usually a machine account in the domain context. And what we're after is the NTLM hash that we can see here, right? So with those details, we will go into the next bit. Okay, so what I need to do, because I want to use Rubius and sniff information for, or rather tickets that could be getting stored on this machine, I'm actually going to get an RDP session on this box. And because we know this user app service is an administrator, we should be able to access this .20 machine through remote desktop. So we'll just do proxy chains -q x free. We are almost at the end, so please bear with me. RDP stroke u app service, then stroke d, the evilcorp.com. Then we're going to supply it the password which we had extracted earlier. Just copy. Actually, do I need this? Yeah, I'll need this at some point. I'll just copy the password from here. And what else do I need to supply? I need to put the quotes. Remember, I told you sometimes these @ signs, this special characters can mess us up. So to make sure that it doesn't misbehave, always put it in a single quote. And then, of course, the machine we want to connect to. So in our case, it's 192.168.1.20. And if all goes well, we should be getting RDP. So remember, we have tunneled all this traffic through Chisel, and now we're actually we're on that network and accessing this machine like we're there as in the same level as these guys. So once we have that, we're going to start a new command session as administrator on the machine. So because we have administrative rights, so we'll just do CMD. Right click this, run as administrator. Say yes. So we have that running. And then what we need to do is to ignore this. Yeah, so even if you do a who am I here, even if it shows your system, I mean, you're supposed to be that app service account. Ah, if I could type. Let's see. La, 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 la. La, la, la. I've had a long day, so please forgive me. I've been trying to practice this for you guys. So anyway, PowerShell minus exec bypass so that we can have a PowerShell session running. Now, what I'm going to do is since we had a Python server running on port, was it 1990? We can use that to pull the Rubius file to this server. So for that, we'll just simply do IEX, invoke web request minus use basic parsing, and single quote HTTP, HTTPS, but HTTP 192.168.125.140 port 9090/Rubius.exe. Then we want an out file. Make sure this is end quote. That's out file. Where do we want to save it? We give it a path of C users public, because public is always writable. So you can put it there, or you can put it in your same directory as yourself. But we'll just put it in the public folder. We'll call this rubius.exe. End the brackets. Should be good to go. I cannot find. Okay. Where is it? Line 1, character 5. Was it 1990? Let me just confirm. Yeah, it's 1990. We have a get to Rubius. Come back to this. If I do LSC users public, do we have here? Rubius is copied. I don't know why it threw this error, but it's there. So we should be good to go. Now, what I was talking about tickets, this is how Kerberos works. Whenever you have a session on a machine, it usually loads Kerberos tickets, depending on which user and what services you've requested for. And to know what tickets are on the machine, you can simply type klist. And this is what I meant by, you can see the app service account is logged on here, and the service ticket for this is towards the KRBTGT account. And we also have LDAP on the domain controller. So that we don't need these tickets for now. So we can simply purge these. And once the ticket, you can do klist again, and you'll see we don't have any tickets. You can see 0 tickets are cached currently on the machine. So the next thing we need to do is we need to request for a ticket as that MS SQL machine. I mean, we need to get the ticket granting ticket of that MS SQL machine. So since we have the NTLM hash, which we dumped from here, we can simply use Rubius to request using the ask TGT and get the ticket granting ticket for the MS SQL machine account. So I'm going to copy this. Come here. Did I use the clipboard? Okay, let me just close this, and I need to start this again, but supply plus clipboard. Is it plus clipboard or clipboard plus? Plus clipboard, so that we can copy paste into it. Yeah, so cool. So we're back with that session. So we will shift to that C user public. Come on. Public folder. Now we're going to run Rubius. We're going to say use the ask TGT module because we want the ticket granting ticket for this machine account. TGT. And the user is going to be the MS SQL machine. We don't need to give it the full domain, but we'll supply domain here. Com, then we supply the, what else do we need? The NTLM hash, we have it. I hope it is copied to this. Let's see if that works. Yay, it worked. Okay, so that's there. And then we're going to say no wrap. So it gives us that ticket granting ticket as a single file. And there you go. We have the TGT of that machine account. Copy this. So just to make it clear, over here you noticed we didn't supply the dollar sign because, and I mentioned here that whenever you see a dollar sign, that's usually a machine account. But now when you're using Rubius, remember the domain controller looks at machines and users as the same. So you don't really need to supply the dollar sign because over here it knows you're trying to request as a user account. So you don't have to supply a dollar sign here, but it's during your enumeration phase, whenever you see user and has a dollar sign at the end, that's usually a machine account. So now that we have the ticket granting ticket for this machine account, the next step we need to do is run Rubius and use the S4U module now. So just go up here, run Rubius. We're going to supply it S4U. Then here we have the ticket, which we got, which is the ticket granting ticket. So we've copied it. We'll paste that here. Then we're going to give it the MSD SPN. And this time I want to get a ticket for time and LDAP so that I'll be able to then use that ticket to remotely access because LDAP and time are used for for DC sync. So whenever servers synchronize and they are trying to make sure that the policies and the user are all on, these are instances when you have multiple domain controllers in a network and they need to share the data amongst each other. There's a tool, or rather there's a protocol that's run, which is called the sync protocol, and it makes sure that the databases are the same across the domain. So of course, attackers have are able to leverage that DC sync utility to be able to dump out information or further details from the domain controller. And for you to be able to DC sync, there are certain tickets that you need, or certain types of tickets that you need, which is the time and LDAP. So here we'll do MSDS SPN for time. Sorry. And that's the domain controller. You have to supply the full FQDN, fully qualified domain name. PC01 evil. Sorry, come on. Evil corp.com. We need to give it we're going to impersonate the administrator user. So come on, typo, impersonate user, administrator. And then we're going to give it alt service. See that we're going to ask for LDAP because I said you need both LDAP and time. Come on. And we're going to use a utility called pass the ticket. So this will now request for those service tickets and inject them into the current PowerShell session that we already have. We run this. You can see it's requesting tickets, and you can see it says even tickets are successfully imported. So now, if I clear this and run klist, we should see the ticket for time and LDAP. We can see the LDAP one has already injected, and that's the key one that we need to do the DC sync attack. So the final bit we need to do is, once we have done klist, we can use Mimikatz to be able to DC sync. So again, here, since we have Mimikatz being hosted on that 1990 Python simple server, again, we can simply do IEX, invoke web request minus useb, HTTP, one 192.168.1. Sorry, not one, but this is 125.140. What's 1990? Invoke Mimikatz dot ps1 close bracket. That should be good. So let's bring that into this machine. Why is that bringing that? Oh, I've left a space. Sorry, there's a typo there. X, I'll just copy this here. That should work. Oh, and then I've also missed the second thing here. X, take it till here. And close that and then close that. So we have Mimikatz now on the box, and we can now do the DC sync. So what we're going to do, we're going to try and get the password for the domain administrator. Come on, behave. Thank you. So we'll do invoke. Invoke Mimikatz. We're going to ask for command DC sync. No, it's LSA dump. Let's say dump DC sync. Then we're going to give it the user, which we want to get, which is our case evil core. We have to give it a domain. And administrator. So if we don't supply a user, the DC sync will dump out all the NTLM hashes of every user in the domain. But just to save on time and to target a specific user, we're going for the administrator account. And that should be it. Yeah. So if all goes well, we should be able to get the NTLM hash for the administrator for this domain. There you go. We have the NTLM hash for this user, which is here. So that means now I have the administrator account for the whole domain. So I can now log into that domain controller. So to do that, I can just simply come to this box here, exit from this. And the beauty about EvilWinRM is you can actually supply a hash. So we will change this to -h. We will change this to administrator. And we'll change this to 15, which is the domain controller. And of course, we need to change this from a hash, from password to hash. And where's that again? Make sure we've copied it. Copy it, come here. There we go. If all goes well, we'll be authenticating into the domain controller, and voila, we are done with the whole thing. If you're an evil guy, this is your chance to create group policies and run your ransomware rampant in the network. Woohoo! We're done. So yeah, any questions? I know I rushed through a lot of things, but I'm happy to answer any questions. And of course, you can always sidebar me when you need to talk. Thank you, Dr. Malu. Is it malware or malware? Oh yeah, and as I said, the flags are always on the desktop of the machines. So if we go to desktop, and we do type, so CLS first, and type that flag, no autocomplete. So we'll just copy paste it. Let's just try that and see what it gives us. Yay! And that would have given you the final flag. Yeah, Stephen, yeah, Oste, that domain was very easy to get to.
Labu.
Yes.
Hello.
Hello. Yes. Kindly identify yourself. How do you speak?
Hello, Labu.
Yes, I can hear you.
This is Olalo.
Yes, Olalo.
James Olalo. Yeah. Am I audible?
Yeah,
Yes,
yeah,
you
we
are.
can hear you.
Oh, yeah. Thank you for that. That was a great presentation. I think I have a one question.
Yes, go
Let
ahead.
me see. Yeah. There's something I've written it down. Let me just open it for my notes. So yeah, so what's the difference between you've talked about kaba roasting and there's something also read about as rep roasting.
Yes.
And
So
and actually I thought when you're saying kaba roasting, I thought you were making up the word. I was like, what is kaba roasting?
yeah. So is there any other question, or I can go ahead and answer that one?
No, you can go and answer that.
Okay, so as mentioned, Microsoft came up with a protocol called Kerberos, which is basically to enable authentication on multi machine environments. And so that users don't have to keep on putting their passwords in and out, the protocol injects those tickets into memory, and it allows them to authenticate to various services. Now, what happens with Kerberos, as you saw, this was discovered, I think, in 2015 by a guy called Tim Medin. And basically, this was targeting accounts known as that had what's known as service principal names. So the way you saw, we looked at the MS SQL server. It had some delegation and some SPNs set to it. And that's how we used the in-package tool to get the hash for that help desk account. Now, the other stuff you were talking about, which is called ASREP roasting, is usually set for accounts that do not have that are allowed to request for a ticket granting ticket without having to supply a password. So it's a very dangerous right to have, but we've seen it sometimes in networks, especially where Unix servers or even like, what are they called? These NASes, exactly, network attached storage systems, because they cannot be joined to the domain, or the account of that NAS system is not a domain user. So it doesn't necessarily have to authenticate and request for a ticket granting ticket from the domain controller. So what happens is those accounts are set to authenticate without need necessarily having to supply a password. So with that, you can literally request for a ticket granting ticket for any user and then abuse it. Either try and crack it offline or relay it into the network and see what else you can abuse.
Okay. Thank you.
Welcome.
Thank you
There
for
was
that.
another, sorry?
No, thank you for that. Sorry.
Most welcome. There was another question that was there in the chat regarding the synchronization of the date. Unfortunately, the NTP update will not work. There's a command that you could have used if you're in the same network. Remember, right now, we have used Chisel to tunnel our traffic through a different network. We've actually pivoted through two different networks to be able to reach where we are. So the NTP update command right out of the box on the Kali machine would not work. So that's why we had to go to using Nmap, find the date and time of the domain controller, and then try and synchronize our machine clock to the skew bit of that machine. Yeah. But if you are like directly in the same network, then definitely you could have simply just used NTP date, and that would have synchronized with the domain controller's time. Nice. Okay, I can see some chats. Yes, Mike, that's actually a nice cheat sheet by Sickboy. Lots of cool stuff you can get from it. There's also a lot more other cheat sheets that are out there, but definitely that's one of the top ones I've seen as well. And sorry, guys, I took very, very long, but we actually went through the full cyber challenge tonight. We actually went from the WordPress to the Docker Escape to the Log4j to the Pwn. Okay, we didn't do the Pwn kit, but if we wanted to get a root on that dev machine, you could have used the Pwn kit to exploit it. So using Chisel, we tunneled our traffic, we attacked the file server, we attacked an MS SQL server, and finally we got a domain controller. So in what was that, like 2 hours, 2.5 hours? Yep. But again, that's with knowing what you're doing and straight for the attack. So for the guys who were at the CTF, this was, I know it was a pretty challenging thing, and we really appreciate everyone for the efforts that they took part in that challenge. Yes, try Hack Me is a good place definitely to learn AD. I believe also Hack the Box has tracks as well now for AD. I mean, because it's something that a lot of people encounter in most corporate networks. It's something, it's definitely something you would want to learn and get into, so that whenever you face those things in your pen tests, you'll be able to pawn or do much more, I wouldn't say damage, but improve the security posture of your clients. And if you're an APT, then don't do these things, because you can just deploy ransomware.
Okay. Thank you so much, Amarjit, for the session, for making time
Most
to also
welcome.
take us through. Yeah. Will we have another? Is there another part that will be on next week?
I
No,
believe,
the main are
okay.
done.
So far what we have covered is just the red team challenges for the B-sides.
Okay.
There's also the blue team challenges, which I believe somebody else will be taking those over. So someone will, I believe someone will reach out and confirm we'll be having the session next week, but there will be more sessions from the B-side challenges.
Okay.
Aside
Perfect.
from the
Thank you.
padlock, we don't think we'll need the padlock.
Yeah, but I believe the physical security bit was a nice touch.
Yeah,
Um,
we were actually impressed with the number of people that were able to solve the challenges.
Yeah, so thank you once again, everyone, for staying throughout the session. So this session will remain live, will remain available on our YouTube channel. So feel free to revert in case you feel there's something you'd want to go back to or listen once again. So feel free to do that. We have hosted Amarjit again before, so maybe you can revert to his previous trainings as well. So again, thank you so much. We will communicate because I know next week we'll have elections, I think on Monday. So we'll definitely communicate if there'll be a session on our social media platforms. And yeah, thank you so much. Thank you, Amarjit. Thank you so much, everyone, for attending. See you for the next session, and good night. So I'll give maybe 2-3 minutes for you to maybe get access to what has been shared on the chat, and then we'll just end the session. Yeah.
Thank you, guys. Good night. Have a safe one.
Good night.